Let's get started. So today, we got caught up in the other lecture. I'm confident we'll get caught up in this lecture too. I never like being behind, but we'll definitely get there today. So we're talking about MIME types last time. We talked about what MIME types are. We talked about encodings, ASCII, UTF-8, and all that good stuff. And I didn't quite get to talk about MIME type sniffing, so let's start there. With MIME types, the browser is, modern browsers are pretty, I'll say, aggressive about fixing our mistakes. So if we have the wrong MIME type, the modern browsers will do what's called MIME type sniffing. It'll try to figure out what the right MIME type is, which often is not what we want. It's elegant, feature, it's cool and everything, but it's often bad for us. We want to disable this in most cases. So what we'll do is disable it using this header. Whenever we send a response, we're going to send this X content type options no sniff, and that's going to say, hey browser, I know you have this cool feature called content type sniffing or MIME type sniffing. I don't want you to do that. It always takes so long to get settled down. What the hell? My other two lectures, it's just so much different across. It's always weird to me how different sections can be different. What's up? Is there ever a case? I don't, but maybe. I don't know. I haven't ran into any case where I'd want to. All right, so we usually don't want the browser to sniff MIME types. We set this header on every response. The homework will say, set this header on all your responses, and we do look for this. It is, as we'll see in a minute, a security issue. So if you don't have this header set on all of your requests, it's just a flat 0 for the objective. Starting with objective 2, it'll just be a flat 0 for objective 2 if you forget this on any of your responses. So make sure you have this thing. What the browser will do is sniff out the MIME type. This header is basically saying, hey, look, browser, I got the right MIME type. Like, you don't have to help me out. I got it right. Generally, a few reasons why we like this. One big thing why I like it is if I have the wrong MIME type, I would like to see an error. I want to see an error. I want to see that I got the wrong MIME type so I can fix it. I don't want the browser to just sniff out the MIME type and figure it out for me and fix my crappy code. I want to make my code not crappy. So I want to disable this and get rid of that. Bless you. And most requests, if you go on the internet and with your browser console open and check the responses you'll get, you're almost always going to see this, or at least whenever I do that, I almost always see this no sniff header set. Most major websites are disabling browser MIME type sniffing. So I'd like to see the error fix it. One of the big issues with this is, say I'm doing my testing in Chrome. I'm testing my app, and everything's finally working. I debugged everything, and when I open my app in Chrome, it works, and I get my final product. I'm happy with it, and I'm ready to release it. I release it to my users, and my very first user opens it in Firefox, and it looks like crap. Everything's busted. Half the stuff doesn't render right, and everything's broken. And one of the things, there's many, many reasons why that can happen, but one of the things that can happen is that you have the wrong MIME types, and Chrome was able to figure out what the right MIME types were. It just figured out what you meant, even though your code was crap. And then Firefox, whatever their sniffing algorithm did, it just didn't figure it out, or it guessed wrong. Its MIME type sniffing just got the wrong MIME types. And you're going to have these cross-browser incompatibility issues because your app was only tested in one, and that one browser, figured it out. So disable sniffing, get your stuff working, and then you know your MIME types are right. Don't have to worry about it after that. You're not worrying on a browser because MIME type sniffing, there's no spec for this. This is just something the browser developers decided to do for us. There's no consistency across browsers of how MIME type sniffing is going to work. So we disable it. Get rid of it. We don't want this feature. And then, of course, make sure our headers are set properly with the no sniff And there is also a security concern. So there's the quality of life concern. Like our code is going to end up better if we disable sniffing in the long run. But there's also a security concern. And this is why it's labeled as security on the homework. And whenever there's a security issue that we're checking for on a homework, I will label it as a security issue. It'll be bold, red letters, the actual word security. You see it on the homework if you've seen it on the homework document. I'll label it like that. There are some things in the past, and I remember to do this in the last lecture. I'll do it right now in this lecture. If there's something that I don't put on the homework document, sometimes I forget. There's something I want to test, and I just forget to put it on the homework document. If it doesn't make it on the homework document, when I release that to you all, when the link goes live on the course website, then you're not beholden to it. Like it's not something you're holding to during grading. So when I forget, like last semester I forgot to label this as a security thing, then it wasn't a security thing. It was just it was graded as a missed header, and you could still get a 2 on the objective. I remembered to label it as a security thing this semester, so it is a 0 on the objective if you miss these. And we're going to talk about cookies later. Cookies, the HTTP only directive should be set on all of your cookies, including your visit counter cookie. But, hey, I forgot to put it on the homework document, so you don't have to set it. So during grading, we're not going to check for the HTTP only header or the directive because I forgot to put it on there. I will hold to that. If I release a homework assignment and I forgot to put stuff on there, that's my mistake. I'm not going to add it halfway through an assignment. A week after it being released, I'm not going to change things. So when you have questions of, is this required for the homework? When I answer those questions during lecture, I'll always qualify it with, as long as I remember to put it on the homework document, it should be required. I meant to have it be required. But you can double check the homework document. If it's not on there, it's not required. So I want the homework documents to be self-contained. There's not like, if you weren't paying attention during this one slide, you suddenly got a 0 on the objectives. We don't do that stuff in 312. Maybe I should, but I don't. Maybe someday. So anyway, MIME type sniffing. This is a security issue. If you don't have this header set properly, it is a security issue. Please, please, please check that you have this set properly. I have had students in the past where they had this header set, they had this string typed in their response, but they didn't do it properly, and the header was never actually set. The browser didn't read the header because it wasn't actually a header, and it did not actually disable sniffing, MIME type sniffing. So make sure you have this set. One of the common things I've seen is the simplest little mistake. Before this header, ending the previous header, and then going on to this one, /n instead of /r/n. That's all it takes. And now that header is treated, that text is treated as part of the previous header. Nothing works right. So to test this, go into your browser console, go into the headers, and make sure that the browser actually treated this as a separate header, and then double check character for character that you have the spelling, make sure everything is exactly correct so that you're actually disabling sniffing, MIME type sniffing. If there's any typos in this, that's cool, you had the right thought, you had that header kind of there, but if it's not exact character for character, the browser's still going to sniff out MIME types, and you haven't handled anything. It had 0 effect. So we need the effect of this. The reason, the security issue with this, is that we're handling user data when you start learning objective 3 on homework 1. We're handling user data, and that data is text. It's going to be JSON, so it's going to be hard for anybody to mess with that necessarily. But if somebody could inject information, or if they could replace our HTML, that'd be tough for them to do. But especially starting on homework 3 when they're uploading images, we have the issue of instead of uploading an image, what a clever user can do is upload a JavaScript script. They can inject some attack code instead of an image. Instead of the bytes of an image, they just send JavaScript. Now, you're going to host those images. When we have an image sharing site, we're going to host those images to all users. We're going to send these images to everybody. And we're going to have a MIME type of image/JPEG or PNG or whatever for the images. We don't want the browser saying, hey, look, you told me the MIME type's image/PNG, but it looks like JavaScript. I'm going to run this as JavaScript. We don't want the browser doing that because now it's a lot easier for a malicious user to inject JavaScript into our app and have that rendered and ran on every single user's machine. We don't want that. So we're going to say, look, this is an image. Yes, I'm sure. And if it's not actually an image, the browser's just going to throw an error and say, you told me that's an image. You told me to disable sniffing. I'm not going to touch this data, which is what we want. If we get the MIME types wrong, there's something else wrong. Sometimes it's an injection attack, and we want to prevent that. That's what makes it a security issue. I still have PTSD from all the times my homework gets updated a couple days before the deadline, and I don't see the Piazza post. Yeah, that's, it's been a while since I was a student these days, and that still hits me. Like, I still don't do that in my courses because I remember being so frustrated as a student. Like, why are you changing the spec? I'm like, especially the times where I actually do the homework early, I got like 10's an exaggeration, but I got a lot of classes hitting me at all angles, and there's a homework I want to get done early. I get it done right when it comes out, and then by the time the deadline comes around, I forgot about the homework, the whole spec change. Oh, it's just frustrating. When I release the homework, that's it. I will not change that document unless I'm clarifying some wording. If I have typos, a sentence that's really awkwardly worded or something like that, I won't change the spec. Same with the syllabus. I won't change the syllabus. If I ever do change the syllabus, it's always to your benefit, but I haven't even had to do that in like 5 years. I don't change the syllabus once it's released. All right, so I already said this. I harped on that enough. I think you get the idea. Make sure you set that header and get your MIME types right. Okay, sending images. Sending images is one of the easiest things you're going to send from your app. The hardest part about sending images, so right from Objective 2, LO2 on Homework 1, you have to start sending images, you're hosting images. Let me back up a second, actually. So to send your HTTP, CSS, JavaScript, that's all text. We talked about text on Monday. So to send that in text, you take that string, you can read the file as a string, encode the string, just hit it with .encode, get the length after you encode it, and then concatenate those bytes to the end of your response. So you're making your response, your status line, your headers, the CRLF, that blank line, and then you're going to concatenate your text after that, and then ship those bytes over the internet. That's how we're sending text. To send an image, we do less. The hardest part about sending an image is everyone likes to overthink it. Don't overthink sending an image. What we're going to do to send an image is read the image file, read it as bytes, len. That gives you the content length. Just get the length of the bytes after you read them, and slap those bytes at the end of your response as the body and ship it. You don't have to do any extra processing. You don't have to do anything. You don't care if it's a JPEG versus a PNG, what the actual encoding is, what those bytes actually mean. We don't care. We're just going to ship it. So don't overthink these images. When you're reading an image, and this is hard to do, it's easy to do this accidentally. It's easy to accidentally make a mistake. So an image is not text. It's not a string. It's not encoded with ASCII or UTF-8 or any other string encoding. It's not a string. It's going to be PNG, JPEG, bitmap, whatever. Whatever encoding it has to encode those bytes, it has some separate encoding, which is definitively not UTF-8, which means if you try to interpret those bytes as UTF-8, you're going to get decoding errors. Because it's not going to follow this byte started with 3 ones, therefore the next 2 bytes are part of the same 3-byte character. It's not going to do that. That's not what a PNG or a JPEG is going to be formatted as, so it's going to be decoding errors. So never, ever, ever treat the bytes of your image or any other binary, non-text binary data, never treat it as a string, or you will get bugs. Conceptually, that's easy to understand, I believe, anyway. If there are questions, I'll be happy to take them. But the problem becomes it's easy to accidentally write bugs. It's easy to accidentally treat your image as a string. It's usually something students do, or developers in general, don't do on purpose. It's easy to accidentally do. So it does get a little bit harder. So when you're reading the file, this is your first chance to make this mistake. When you're reading the file, any file I/O you've done in the past in courses and most tutorials online, a lot of it's going to assume that you're reading the file as a string. So you have to make sure that when you're reading the file, you read it as bytes. You read the raw bytes of the file, never accidentally convert it into a string. And then once you read the bytes of that file, never try to decode those bytes into a string. If you read the bytes of an image from a file and hit it with a .decode to try to convert it to a string, it's not going to work. It's either going to corrupt your data or crash your program. Either case is bad. So we don't want to ever accidentally convert it to a string. So when we have an image, what we do want to do is take our status line and our headers. We can do all that in the world of strings. We're going to create our headers of our response, everything up to that blank line, that CRLF. All that can be in the world of strings. And what we're tempted to do, one mistake that we're tempted to do is take the contents of the file, encode it as a string, concatenate the headers with the body, with the bytes of the image, and then encode it as bytes and then ship it over the internet. That's what we're tempted to do oftentimes, because that's how you're going to do everything before you start hosting images. That's how you can do your HTML, CSS, JavaScript, all your text-based data. But when you get to an image, what we want to do is just a slight tweak to this arrangement, slight tweak to our approach is take the status line, the headers, that CRLF, the blank line, all of that we can do in the world of strings, encode it first, encode the headers into bytes, and then concatenate that with the bytes of your image. Then your image never has to become a string. Concatenate in the world of bytes. So don't get in the habit of just encoding as the very last thing you do before shipping it over the internet. Encode, then concatenate your 2 byte arrays, which is just the plus operator in Python. That's why I like Python in this course. A lot of the little details don't get in the way. We're just going to plus those together. It's just like string concatenation. And then ship it. Now your image never had to be converted to a string. Then content type, and as I mentioned, content length. When you read the bytes of the file, you have the bytes of that image in some variable as a byte array. len, that byte array, that's going to get you the length. Len is pretty powerful in Python, pretty versatile. Any questions on any of that before we get into today's content proper? Let's do it. And I am going to say the word cookie way too many times in this lecture. It's inevitable. Can't avoid it. All right, so HTTP is stateless. We mentioned this before, where HTTP, the protocol, when our server is handling an HTTP request, the only thing we have, the only information we can go off of to handle that request is the request itself. The request must be self-contained. So we can't say, oh, I got this request. My example before was, oh, I got this request. Oh, this is from that same person who just sent me that request earlier. Let me use that information and formulate my response based on the fact that this is the second request from the same person. We cannot do that. It's not part of the protocol. It's not how it works. We get a request, and we handle that request, bless you, just based on that request. This is what we mean by HTTP is stateless. So it could get both the size in bytes and length of string, or is that the same thing? Oh, my God, no. No, I failed. The length of the string is not the same as the length in bytes. Or maybe this is what you meant. It's the same. You do it the same way in Python. Len of a string, len of a byte array, it's the same syntax. Hopefully that's what you meant. But those might give you different values. Yeah. Yeah. Yeah, the body's always, by the time, I'll rephrase that a little bit. By the time you send your response over the internet, it has to be a byte array because the internet only handles ones and zeros. Yeah, the body will always be bytes. Either it's string data and you have to encode it into bytes, or it's an image and it's already bytes. But it always has to be bytes. The internet only knows ones and zeros, and it does affect our code. Like, we have to care about that in our code. Everything, when you do send all on your TCP socket, it's got to be bytes. It can only be bytes. By the way, I say a lot of things. Like, I realize I have not done a demo of running the server in lecture yet. I don't know when, if, hopefully by the end of the semester I'll be able to, but when I'll be able to do that. The plan this semester, which most of you have no reference for that, I guess. But in recitation, that's where they're going to do all the demos. So if that doesn't make sense when I say ship it as bytes and stuff like that, that's what they're doing in recitation, is showing you the demos of what that actually looks like in the code. So if you're not going to recitation, please go to recitation, because that's where I've offloaded all my lecture demos. Because I don't know if I can fit them in lecture anymore. All right. So we pretend that we have state, because we actually want state. We want some sense of state on the internet. My go-to example I've already given this semester is when you visit a website and log in, you want that site to remember that you've logged in. So you kind of have this illusion of state. Even though HTTP doesn't have state, we still want to have some persistent state with a website that we visit. And we do that through cookies. Because without state, man, if we had to do our username and password every single time we did anything on any page that we're logged in on, I probably just wouldn't use the internet. Or I'd use it as read-only. I wouldn't use it for any private data that needed authentication. So we use cookies for this. This is our solution to kind of pretend HTTP has state. Now, the HTTP request is still self-contained, but it will contain a cookie. And when we log in, we're going to... Oh, let me back up. I'm sure you're all familiar with cookies, but just in case, let's give a quick overview of what cookies are before we get into the technical details of how they work. Is a cookie, we're going to set a cookie. The server is going to say, hey, browser, set this cookie. And whenever you send me a request after this, make sure you send that cookie along with it. And for authentication, we're going to set an auth token as a cookie. And then every time we get a request, we're going to read that cookie, check the auth token, go to our database, and look up which user we gave that auth token to, pull that user's profile, and then we can start generating custom content for this specific user with the reasonable guarantee, reasonable assumption, I should say, that this is a legitimate user who did authenticate with their username and password at some point in the past. So the request is still self-contained, but it contains a cookie that we're going to use to look up, go do a database lookup and get some more information about this user. Then we can go to the algorithm and get some custom data hosted, served up to this user. Since cookies work through headers, I didn't mention that on the previous slide, but it said it on the slide, works through headers. Cookies are 100% header protocol. It's all through headers, which does imply that it's ASCII only. So for what it's worth, your cookies cannot have non-ASCII UTF-8 characters. Headers are ASCII only. Cookies are headers. Therefore, QED. ASCII only. And we're going to use these two headers specifically. So when we want to set a cookie, when we get a request from a user, we want to say, hey, user, here's a cookie. Please set this cookie and send this cookie to me whenever you make a subsequent request. We're going to use the set cookie header, set-cookie. When we use this header, we're going to say, this is a cookie that I want you to remember. And then whenever that client sends us another request, all subsequent requests are going to have that cookie in a cookie header. That's where we're going to get all the cookies from them. So we use headers to set cookies, tell the client to set cookies. Client sends us those cookies in headers through the cookie header. And I'll mention it now. It's my very last slide on these slides, but I'll mention it now. You can also set cookies client-side. We won't do it in this class. Don't do it on your homework either. We're all about server-side. We're all about back-end in this class. But you can, so if you remember back to 199, I think you all took it with Alan's module, where he did have you set a front-end cookie in JavaScript. It's a little bit different structure. It still sets a cookie all the same, but just the syntax, things are a little bit different. We're going to do it server-side through headers and using the set cookie header on our HTTP responses instead of setting them through JavaScript. But front-end cookies, you can set cookies directly on the front end, just not something we'll do in this course. But I want to make sure I mention it because that's how you've set cookies in the past if you're just following the CSE, at least in the curriculum, if you're following the CSE course structure. What does it mean by HTTP stateless? So when you get a request, that request is self-contained. You can't use... you can use information outside that request. We're going to go to our database. But that request has to be self-contained. It has to have all the information you need to be able to make those database lookups and generate the response. So like if the user sends a second request after logging in and doesn't send that auth token and says, hey, you remember me, right? That would be a stateful protocol where it expects us to remember this user and have this idea of like a user session. HTTP doesn't have any of that. So we have to add that on top of the protocol through cookies. I mean, each request. Yeah, Eric, that's you summed it up. I should have just read your whole thing and said yes. Can you rephrase it? I'm not understanding. I don't know if I have another rephrasing in my head. I'll give it a quick one. I want to move on, but I'll give it a quick one. Like TCP has the three-way handshake when we have a session that we're establishing, and if we want to send a message with 1,000 packets, like we're creating a session, we have state. We have an association between those 1,000 messages, like a persistent connection and everything. When I get all these packets, I'm associating those packets with the other packets, sequencing them together with their sequence numbers. That's a stateful protocol. HTTP is stateless. We don't do the same thing. If I get 5 requests from the same user, I'm treating every single request as a completely isolated conversation with that user. So it's like 5 separate conversations with the same person instead of 5 interactions of the same conversation. HTTP doesn't link those requests in any way at all. No meaningful way. Every single request has to be handled in complete isolation. It's the best I got. That's the best I can do. We can talk after class if that still doesn't make sense. All right, so set cookie, this header is going to use key value pair syntax with an equal sign, which is syntax that we're getting familiar with if you weren't already. We use this a lot on the internet. Set cookie, if I want to set a cookie named ID with this value, this is the syntax I'll use. If I want to set a cookie named visits with the value 4, this is the syntax I'll use. I don't have much else to say about that. That's the syntax. So I'm going to use this header on the response that I send to the client. So client requests my home page. I'm going to send a response, and that response can include a cookie, like set a header that says set cookie visits of 4. That means this is the 4th time that you visited this page. And when I get another request, they're going to send me cookies equal 4 or visits equals 4. I'm going to increment that. Set cookie visits equal 5, and send that on my response the next time. Cookies are unique. You can only have one cookie with one name. So when I set visits equals to 5, and they have a cookie called visits equal to 4, that will overwrite their old value of visits and replace it with 5. Sometimes we want to set multiple cookies. This one kind of got a big asterisk. I got to talk about it for a little bit. But set cookie, we can only set one single cookie with a set cookie header. So what happens if we want to set multiple cookies, which is something we'll want to do starting with homework 2. We'll have our visit counter and our auth tokens. We'll set 2 cookies in the same response. We do that by using 2 headers. So we'll have 2 headers with the same name which is allowed. HTTP lets us do this. We can have two headers with the same name. So we have two set cookie headers, like in the previous, oh, that went to the other slide deck. In the previous slide, these two headers could be in the same response, and we'll use that to set two separate cookies, the ID and visits. That's legal in HTTP. The browser's expecting it. The browser will know what to do with this. So we can do that. The asterisk is in your server, on server side for your LO1 of homework 1 or throughout the whole semester, you don't have to worry about this in your parsing in the confines of CSE 312. And because we're never going to get a request from the browser with two headers with the same name. That's just not going to come up in 312. And just my days of developing for the web, I've never actually seen a browser send a request with multiple headers of the same name. I've never actually seen that come up. But out there in the real world, you'll use libraries. Libraries will just handle that situation for you. In this course, we're not going to worry about it. So your homework 1, LO1 code, you're putting your headers in a key value store, which is not going to allow duplicate keys. It's perfectly fine. You don't have to worry about that situation. I will not test for it. You don't have to test for it. You don't have to handle that situation. We're just going to treat them as unique header names. The browser has to worry about that because we're going to set multiple cookies, and I see that use case out there in the world all the time. Most sites you go to are setting multiple cookies in one response, and the browser will have to worry about that. Server side, we're not going to worry about it so much. And then the cookie header, when we get the cookies back, we do get them all in one single header. So good, our code didn't break. Our parsing code isn't going to break here. We get every single cookie in one header called cookie. It always bugs me. I always think it should be cookies with an S. Even if you have multiple cookies, it will be singular still. The cookie header has as many cookies as are set that the browser is sending. So the cookie header is going to have every single cookie separated by semicolons. So multiple cookies separated by semicolons, any number of cookies in this header. When you're parsing, make sure you handle your leading or trailing spaces. Other than that, I don't have much to say about this. This is the syntax. That's what you got to parse. Split on semicolons, get rid of extra white space. Split on equal sign. That'll get you there. But a question you I'll go as far as say should have, is, hey, look, when the browser's sending us cookies, multiple cookies, one header. When we're setting cookies, why ain't we setting multiple cookies in one damn header? Like, why don't we just use the same exact syntax, right? That should be the question you have. Like, why would we bother with multiple headers? And the answer is directives. When we get the cookies from the browser, we are getting key value, period. We're getting the name of the cookie and the value of that cookie. That's it. Not getting any extra information about the cookie. But when we set a cookie, we can set any number of directives associated with that cookie, and these directives are semicolon separated. So if we're using semicolon to specify our directives, how are we also going to use semicolon to specify that there's an additional cookie? We'd have to have some extra delimiters and extra syntax to specify here's the next cookie with its directives. And when we only have ASCII to work with, there's only so many special characters, and every special character we reserve, that's a special character you can't have in the names or values of your cookies. It just gets messy. So we use multiple headers, and semicolon means here's another directive. So what are these directives? And we're actually going to go through every directive. There are 5 directives. We're going to go through every single one of them. We'll be comprehensive because there's only 5. Why not talk about every single one of them? Some of them we won't use in this course. 2 of them, actually, we won't use in this course. Expires, we won't use in this course, the very first one. But I want to talk about all of them because they're all there's only 5. Why not? And 43. I thought I'd be at 435 on this slide. So I almost hit it. But in 2 minutes, this cookie's going to expire. So expires is the first directive we'll talk about. And so we're going to specify the name and value of our cookie, semicolon, start a directive, and expires equals, this is the same key value pair syntax, expires equals, and then a timestamp in this exact format. This has to be exact. And if you do remember from 199, you use this exact same format when you set your cookies. If you didn't set your expiration date like this, the front end won't set your cookie. So we have our expiration date in this exact format. This means, hey, browser, set this cookie with this name and this value. And after this timestamp, don't send this cookie to me anymore. Get rid of that cookie. It's done. The one we'll actually use in this course, because it's way simpler and fits our use case much better, is max age. This is a number of seconds that need to elapse before the cookie's expired. So if I say max age is 3600, I'm saying this cookie should expire in 1 hour after it's set. So when the browser gets that response, it's going to start a clock. 1 hour later, that cookie is going to expire, and it's no longer going to send the cookie to us, to your server. Just much easier. Usually this is, at least for our purposes in this course, this is our use case of I want this cookie to last for this long, and we don't, at least in this course, have some like fixed timestamp in the future where we want all of our cookies to expire, which might be the use case for some situations, just not in 3.12. So we'll use the easier syntax. Cookies do not sound like real word anymore. Yeah, sorry about that. There are a few lectures like that where it's going to be like that. This cookie lecture, cookie, is one of them. I can't think of another one. WebRTC maybe, WebSocket. No, those aren't good examples. All right. Anyway, so we have expires and max age. We needs a little strong. We should set at least one of these. On the homework, it's required to set at least one of these. Usually expires, that's just the easier one. The max age, that's the easier one. No need to mess around with timestamps. Because timestamps, usually you would get the current timestamp, add whatever time you want to it to generate your new timestamp and set that. Like, why not just use max age at that point? Unless your use case is specifically timestamp based. But if we don't set either of these, what we have is a session cookie. A session cookie is destroyed when the user's browser session ends. And we're overloading the word session a bit. Like we kind of use cookies to create sessions like login sessions, but session cookies are a separate thing that's related to how long the cookie is going to live. When we have a session cookie, that cookie is deleted when the user closes their browser. As soon as they close their browser, that cookie's deleted. Done. It's over. And note that I'm saying browser, not tab. You can close the tab, every tab for that website, and then go back to that website. That cookie's still going to be set if it's a session cookie. But if they close the browser, like legit close down every window of that browser and shut down the browser, then the cookie's deleted. Or if they restart their machine, cookie's deleted. So if we want either expires or max age, so we can control how long that cookie lives, so we don't have these session cookies. To check for this, and please check for this, I don't like students losing credit because they thought they set their directive but did it the wrong way and it didn't take, and then they had session. I'll try to tone down the cookies. They have session things, pastries. That doesn't work. Instead of an expiration, and that's not why I'm here. And every time I say it, I'm like, man, I ain't saying it a lot, but I have to. It's the cookie lecture. What am I supposed to do? So the session cookies, if you go into your browser console, go to the application tab and take a look at your cookies, it'll say under the expires column, it'll say session. It'll say the word session there. If it says session, your directive didn't take, and you got to fix something, whatever your syntax is. Maybe you messed up the capitalization on max age or something, or you missed the dash. It's little things will do it. It doesn't take much. So make sure that you get that exactly right and you don't have that. The TAs, they'll go into that console and they'll check. If it says session, you're losing some credit. You might not get that objective. Depending on if that ends up being that should just be a 1. A 1 or a 2. It probably should be a 1 and not get the objective. you pay attention to the wrong reason. Maybe I should say cookie in every lecture a whole bunch of times. All right, so we don't want session, we want an actual expiration timestamp associated with these things. The security directive, this one we won't use until homework 5. Again, as long as I remember to put it on the homework. I forgot the past 3 semesters since I started doing that version of homework 5. So the security directive means only send this cookie over encrypted connections, so only when we're using HTTPS. Everything in homeworks 1 through 4 is HTTP, which means if you set the secure directive on homeworks 1 through 4, your cookies just won't be sent. You just won't get them. You'll never see them. So we don't want to use this one until homework 5 when we actually do have HTTPS with certificates and all that good stuff. HTTP only, I meant to have on homework 1. I'll have to make sure it makes it to homework 2, but in chat, in the earlier lecture, they were saying that I forgot to put it on there, so I guess it's not required. But it was meant to be. HTTP only means that you can only read the cookies through HTTP headers. The other way to read cookies is going to your running JavaScript and accessing document.cookie. That's going to give you all of the ones that have been set. It'll give just print them to the console if you just, console.log. I was blanking on it. Console.log, I almost said system.out.println. Console.log this, and it'll print them all out to the screen, except the ones with the HTTP only directive set. So we like this one. If somebody, in the off chance that somebody does inject some JavaScript, maybe we didn't disable MIME type sniffing, they were able to get some JavaScript in there running on everybody's device. We don't want them to write JavaScript that accesses this variable, gets all these things, and sends them to their server and just starts stealing everybody's cookies. That's bad. We don't want that to happen. So the HTTP only gives us one extra layer of security that even in the face of a JavaScript injection attack, we can still protect these things with this directive. So we like that. The user can still see their values. They can go into the browser console and see their values for these. So they're not completely hidden from the front end, but it does give us an extra layer of security. Somebody can't get it with JavaScript. They have to have physical access to the device, which is, of course, a lot harder in most cases to get. Path, this one we won't use in this course either because I don't like it and I think it's dumb. But path means only send this cookie on request with a path that starts with this prefix. And maybe this is useful for very large apps with lots and lots and lots of paths, and you're worried about cluttering up your HTTP headers. Maybe that's the use case for this. And there are some organizations where they have one domain name with many different apps and services, each with different paths. In that case, this would be a good idea to use your path directive to only have the cookie sent to the app that you're currently using. That would make sense. But in that case, I much prefer either different domain names entirely or different subdomain names for each app. And that's going to prevent this issue of needing the path directive. So we won't use it in this class, but it exists just for comprehensive directive coverage. That's path. And same site, our last one. Same site controls when cookies are sent in relation to third-party requests. So a third-party request is when you're visiting one page, and that page wants to make a request to another page. I'm saying page. Why am I saying page? When that site wants to make a request to another site, I feel like that's still... Origin is the right word, but I don't want to jump into that terminology quite yet. Screw it. So when one origin makes a request to another origin, this is a cross-origin request. So if I'm at one site with one domain name, it goes by domain names anyway, I should just say domain name. When I go to a site with one domain name, and that site wants to make a request to another domain name, usually when it's like connecting to an API or something, are the cookies sent on that request or not? Another example, if you have a page that you make, you have your HTML, and you put an image there, and instead of hosting your own images, you put the full URL of an image that's hosted at another server to request that image. Are the cookies for that server sent on that request? Yes or no? Well, it's the same site directive that's going to control that. Either none, which means cookies are always set for every request, first party, third party, who cares? It's always sent, always gets the cookies. If you use this directive, it is required that you use the secure directive as well in conjunction with it. It's just a rule. That's the browser's not going to send your cookies if you do same site none without the secure directive. That cookie's not being sent on third-party requests. Strict means never. Only send these cookies on first-party requests. So when somebody's visiting your site, your app, your cookies are sent on those requests, but never, ever on third-party requests. And lax, this is the default and most common, being the default. This is the probably the best, too, like the most useful one, is sometimes. It's somewhere in the middle here. So it's sent on every first-party request still, and third-party request when navigating to your site, and I don't think I got it in the slide, and every single GET request. So in that image example, the cookie would be sent if it's lax, that cookie that is sent on that request. If it's a link, if I am at one page and I click a link to navigate to another page on a different origin, that the cookies are sent there if they're lax. And also, if it's a form, do we have to get into that right now? I already said it, so let's do it. If it's a form where somebody has a form on a website and that form submits to another website, a whole nother domain, a whole nother origin, then the cookies, the lax cookies, are sent on those requests as well. Because a form will reload to the page. It is a navigation to that page. So those are also set. Since I don't want to go on too much of a tangent, but as long as you're using HTML forms, that's true. A lot of forms on the internet are like custom JavaScript, made from scratch kind of stuff, so they don't behave like forms. But if it's a vanilla HTML form, then those cookies are sent. What do you mean by first party and third party? First party is when you're on a site. Every request is a first party request. If you're on a site that makes a request to another server, it's a third party request. And client-side cookies I talked about earlier, so I didn't have to talk about them now. But for what it's worth, you can set cookies client-side. We're not going to do it in this class. Please don't do it on your homework. It's not allowed. You can't do it on your homework. How do we determine which party is making the request? That's actually a pretty deep question. We'll talk about it when we talk about cross-site request forgery next week. But it's a longer conversation than I can fit right now in 0 minutes. My music's been slacking.